Well, it sounds like we could make our own.
That's what I'm thinking. We might have to make our own chart.
Do we do it right now?
No, not now. Maybe I
Sunday?
might have a weekend off here coming up. That isn't our trip. Possibly. Oh, we did find somebody finally.
Oh, you guys hired someone?
Possibly. She has to go through all the testing still. But we might have found somebody. So this November, I might finally get a weekend off. I'm gonna get so much and so little done all at the same time. It's gonna be great.
Yeah.
Oh my god, finally having 2 days off in a row is gonna be. Anyways, air is a compost primary of nitrogen. Seawater, okay. It's a mixture of okay. All right. Air, okay. Each of these mixtures can have different properties of its constituent compounds. For example, metallurgists vary the relative amounts of copper and zinc and brass to tailor the metal's properties to its intended use. The higher the zinc content relative to the copper content, the more brittle the brass. I guess that makes sense. Mixtures can be classified according to how uniformly the substance within the mix. In a heterogeneous mixture, such as oil and water, the composition varies from one region to another. In a homogeneous mixture, such as salt water or sweetened tea, the composition is the same throughout. Homogeneous mixtures have uniform compositions because the atoms or molecules that comprise them mix uniformly. Remember that the properties of matter can be determined by the atoms or molecules that comprise it. I should just send this to our cousin.
You should. Just take a picture of it or something.
Yeah. Yep.
Do they use the same textbook?
They don't use a textbook at all.
Oh.
They don't have one. You know, back in the day, not having a textbook meant you're poor. Now it just means that everything's digital and you're hip.
Do they have like an online book at all, or no?
Not that
Or
I'm
are they
aware.
just expected to take notes in class?
I'm not sure how it works, to be honest.
Because I guess when I was in school, did I have textbook?
I did. This wasn't it. We had a different textbook.
I don't recall. Well, the thing is that we had notes that we took. We had like a note, like PowerPoint slides that you'd print off and then you fill in the blanks or whatever. We had like a note packet that we filled out. And so I think that was our textbook, but I feel like there was a textbook, but we had to check them out. Like it was not needed for the class. But if you wanted to check out a textbook, just for like a homework assignment or something, then you could. And I think that's the way physics worked too, because I don't ever remember carrying a textbook around. I think math was like the only class where I had to bring a textbook. All the other classes, it was like, oh, I needed to borrow the textbook for like a homework assignment. Otherwise, I rarely had a textbook, I think, in high school. College, on the other hand, that's a completely different story.
So yeah, that's weird. Having to check out a textbook. But no, I should probably just lend her this for the for the year. Just be like, here, this is better than whatever the hell your teacher gives you.
Oh no, we need to make our chart first.
Yeah. Well, she won't need the chart after this unit.
That is true.
But we can give it to the
No,
teacher.
but we want a chart because we have our just own personal desires.
Yeah. We're going to have to do one like with alloys and crap, because like an alloy can be both.
Well, yeah, I was thinking like we make one that's like super complex.
Oh, great. Oh, great.
I was thinking, yeah, you can find some basic chart on Google Images.
Right.
I was thinking we make like some that's super complex.
Oh no. I'm still haven't finished that
not
periodic
what you- is
table,
that not-
you know.
Is that not what you had in mind?
No, I mean it is. I just never, But I'm like, is this gonna go to the realm of I never finished that periodic table, so here we are, doing another thing?
Oh yeah. Wait, you never finished it?
No,
Your master, because you were gonna make like some masterful periodic table that was like beautifully color coded for like all these different things.
yeah. Well, I was thinking about it, and I think you won't. And it needs to be like, so because the problem with the periodic table and this one kind of, well, this one falls into the same problem. And it doesn't address it. Like these down here, we don't know if they're metals. We don't know. And some periodic tables, yeah, they don't label them. But the problem is we also don't know what state of matter they are. So you need to label that as well. But the problem herein lies is this is still technically a noble gas. This is still technically a halogen.
I was still gonna ask that. Is Organ S on a noble gas? Is that confirmed?
It's a part of that.
It should be, but is it?
We don't know. I don't think we can know.
Its half-life is too short.
Yeah, that's the problem, right? We can't confirm whether it's a gas. A lot of people wonder, like, these heavier elements, do they even, act like they should? Like, if we follow this here, this theoretically might not even be a gas. It might be a metalloid. It's so heavy, it may act like a metalloid, unless it may be a solid. We don't know. Because when you look at the halogens, right? The halogens, as they become less reactive, they become solid to the point where now astatine down here is a metalloid. It's no longer just a non-metal. Because you have fluorine, which is a gas, chlorine, which is another gas, bromine, which is a liquid, and then iodine, which is a solid. But then you get so heavy with iodine, because now you have an F orbital. You didn't have F orbitals in here. These just had Ds. These two, anyways, had Ds. Now you have an F orbital introduced in there. This is just theories that I've had. I don't know if it's true. I don't know what kind of studying has been done. I don't know if anybody actually cares to figure that out.
Well, because I have looked at the color codes, and it has always interested me, It's like, yeah, if you follow the column, it's a noble gas, but if you continue the metalloid little trend you got going on, then
But what the hell is hydrogen?
Hydrogen is a diatomic nonmetal.
Diatomic nonmetal. Okay.
Yeah, along with the other Brinkle hops.
But see, the thing about hydrogen is, though, so that's the other issue. Is the periodic table strictly in reference to nature and nature alone? Or can it be... Because we can make hydrogen, in theory, a metal.
Mm-hmm.
And, technically, at the center of Jupiter, there's liquid hydrogen. It's like a metallic liquid. It's metallic, theoretically. It acts like a metal.
It's a solid.
But if you go deep enough.
Yeah. I think Jupiter's core has literally solid hydrogen.
Right. And solid hydrogen...
Oh, no. Is it solid hydrogen or solid oxygen? I think it's solid oxygen.
It's solid hydrogen.
Oh, it has salt... Okay, I thought it was solid oxygen.
It actually has liquid hydrogen and then solid hydrogen, I think. Supposed to. It might be liquid helium and then solid hydrogen. I think. Solid hydrogen, though, it's a wild substance. We've tried to make it here on Earth. It's a room temperature superconductor.
What is?
Solid hydrogen.
Oh.
And it'd be a phenomenal rocket fuel. Because now we don't have to worry about trying to store gaseous hydrogen. Or liquid hydrogen, I guess. At cryo temperatures. We can store it as a solid. It'll be the most hyper energy dense. Be insane. Of course, now you have a hybrid rocket. And I don't know if you want a hybrid rocket. I don't know because you can't. I don't think you can. I guess you can stop it in space, or you can stop a hybrid rocket from burning. Once you just turn the oxygen off, it stops. So,
Yeah.
but you can't throttle it. So, it's just on off. Well, unless the amount of liquid oxygen, I don't know. But see, no one has to think about that because we don't have that substance easily available. That's the thing, right? So, hydrogen, to most of the time, is a gas, but we can make it act like a metal and stay as a metal. That's the thing. Once you pull the pressure off, it stays as a metal. It doesn't, return to gas. So, what is it? I don't know. Hydrogen, I always, with my table, I think hydrogen was just going to be a white square. It's a gas.
Oh,
it would be labeled as a gas, but it will just be a white square. So
it's not going to be included with fluorine, chlorine, bromine, and all that?
No. Because it can be all of that. As a gas, it's a non-metal, but in a solid form, it's a metal. It's literally, it acts like lithium. Softer than lithium.
Solid, it acts like a metal.
Yeah. What are you? That's the issue with hydrogen. Hydrogen's just complex. But for kids, I guess it kind of depends. If we're building a periodic table meant for,
we want to build an advanced one, one that's as little hand wavy as possible.
Right. So hydrogen will be its own thing.
If you want a kid's periodic table, just go on Google Images. No.
Well, this is a kid's. This is as basic as a periodic table as you can get. You literally cannot make it any more basic.
Which one?
The one in the textbook.
Oh, yeah.
It sucks.
Well, how many different... Wait, they just have 3 categories?
Yep.
Well, I can't quite read them. What are they?
Non-metal, metalloid, metal.
Ah. Yep. That is probably about as basic as you can make it, yeah.
Yep. They don't even label state of matter.
Yeah. Oh, yeah.
They don't even label if it's synthetic or not, either.
Yeah. Yeah, so that is probably as basic as you can make it, yeah.
Yeah.
No, but I want to make one that is as little hand wavy as possible.
So, okay.
And that's just filled with all these intricacies.
So my biggest problem... technetium, right? It means synthetic, right? And plutonium, we have to make it, but theoretically,
you can't find it naturally on Earth?
Theoretically you can. Atoms at a time, in the right conditions, in the right minerals, you can find technetium. Because actually, I know we've found technetium because have you ever heard of the natural Have you ever heard of the natural nuclear reactor?
No.
So there's a place in in Africa somewhere where there's a deposit of uranium, and this water runs over the uranium, and it sustains constant fission. There's enough concentration of uranium, and the water modulates the neutrons enough to where you get fission products that you can only find in nuclear reactors. Technetium, if I'm not mistaken, is one of them.
It's called a natural nuclear fission reactor?
Just look up natural nuclear reactor.
Oklo, right?
It's a natural fission reactor is a uranium deposit where self-sustained nuclear chain reactions occur. It was a theory, but then we found it. Locating Gibbon, yeah. Discrepancy in the amount of isotope. Normally the concentration is samples. 0.6 cents difference, blah, blah. Ruthenium. I thought they were finding technetium here, but I'm not sure. But I swear you can find technetium in minerals. Some minerals that are radioactive, you can find it. Because I think molybdenum, if you just... What's the atomic... I have a periodic table right here. What's the atomic mass of molybdenum? 95. Never mind. Okay. I was thinking molybdenum might be 99 or like 98. So if you had a molybdenum 98 next to a neutron source and you bombard it with enough neutrons, it would turn into molybdenum 100. Sorry, molybdenum 99. And then via a beta decay, which we actually, fun fact, the only reason why I know this is because this is how we use technetium in the medical field. And to have a constant supply, we take molybdenum 99, which radioactively decays via the beta process. And when that happens, it releases an electron, and one of those neutrons turns into a proton. So you get technetium 99. So, but I think it's...
that?
What'd you say?
Well, it started with molybdenum.
Yeah, molybdenum 99 radioactively decays into technetium 99, which then decays into something else via probably like an alpha process or something.
And this is used in the medical field?
Mm-hmm. Yeah, it's in your, if you grab your elements book, it's in there.
Ah.
Mm-hmm. If you've read it all the way through, like I have.
Well, about that.
I've read it multiple times. So.
Remember when we said we could have a book club?
We still can.
We still can, and we probably should.
Probably should. No, so yeah.
We have all the chemistry books.
We do. No, well, I have more than you, but we do, yes.
We have the Theodore Gray edition.
Yeah.
Chemistry.
But no, back to the periodic table, though. So, protactinium, technetium, neptunium, I don't know. I don't, and I think plutonium, you could probably, I don't know if you can find it in nature, but theoretically. On Earth, that's the other issue, right? In space, you could probably find plutonium. Shortly after a supernova, you could find plutonium. Hell, you could find all kinds of exotic elements shortly after a supernova.
Yeah. Well, they predict, what is it, after element 120, there's like this island of stability.
Yeah, but I thought when they reran the math, the stability meant like, instead of nanoseconds, we were talking, instead of like pico and nanoseconds,
well, yeah,
we're talking
that's what I'm going to get into. It's still short-lived, like seconds, but it's seconds, not nanoseconds.
Right, which is quite a bit. We could study it. The problem is nobody's working on it.
Yeah.
The problem is we don't have. So we use a specific type of calcium. Last I remember, because it has a shit ton of neutrons. And then we bombard a target. The problem now is, the problem now is, to get to element 119 and higher, we either A, change the composition of the target, or change the composition of our projectile. The problem with changing the composition of the projectile is that it now has a higher likelihood of not working, because it's too heavy and it breaks apart when it on impact with the nucleus of your target. But the problem with changing the target is we now have to make the element that we're targeting. We have to use such a heavy element that it doesn't have a very long half-life in and of itself, and it's hard to make large amounts of. That can sit there for a long period of time and be bombarded by this calcium.
Mm-hmm.
That's the problem. So we may never be able to, without the proper funding anyways. I mean, I guess if you pour money into the problem, they can probably figure it out.
Yep.
Have 2 cyclotron beams, one making, I don't remember. Let me look at a periodic table here. I don't remember what the target was supposed to be. Was it? Yeah, I think it's Rutherfordium. How do you say that?
Rutherfordium.
Rutherfordium?
I say Rutherfordium. I don't know if that's right.
Well, 104, I think, is the target. I think has to be the target now. And if we want to keep using this calcium, I think. But I don't know. So, but anyways, we are kind of at the end of this podcast. So so
is that what you wanted to talk about?
Yeah, that was.
Oh, I didn't know if you had an actual segment.
I don't think so. Talking about our cousin's homework that was the best one. And then, just... Mm-hmm. Yeah, there's not enough information to share about the new coworker yet to talk about that.
But they just started.
They haven't even started. Like I said, they have to go through the testing phase. They could fail, and then we're back to square one. Oh, we had a guy come in today. I'll tell you after. It's oh my god. But I don't really know. But anyways, I don't know. I didn't. It wasn't really. I didn't have anything specific to talk about. I'm deep into chemistry right now. Her asking me about chemistry, and then doing this element series for my shorts.
Yeah.
It's got me thinking. And then Luciteria is running a special this month.
Oh, really?
For 10% off.
Well, the month's almost over. You better hurry.
Yeah, I already did.
You bought a paycheck's worth of stuff?
A what?
I said you bought a paycheck's worth of stuff?
No, not a paycheck, but I bought a good amount.
A good amount.
Yeah, we'll do it after the podcast. Anyways, I'd like to thank you all for watching. Please like, comment, share, and subscribe. New podcasts every Friday as long as we're not on vacation. 12 p.m. Central Time, and good night.